Thank you, Madam Chairman. And with permission, I'd like to introduce 3 charts to go with my comment, if I might.
Without objection.
I'd like to ask Dr. Dunn and Dr. Shepard a question about the deep ocean heat content and the relationship of CO2 to that, and whether or not it's leading to stronger storms and what might happen if we can't arrest the rise in sea temperatures. This is a chart showing the rise in sea temperatures since the early 80s, particularly the Western Atlantic, Western Pacific, and Gulf of Mexico. This is a chart showing the dramatic rise in the deep ocean heat content. And then this third one is one showing the same rise and breaking it out both above and below the 2,300 meter demarcation line. Thank you.
Yeah, great question. So we know from the data that much of the warming is going straight into the ocean by a large amount, rather than warming up our atmosphere. And in fact, if all the warming stayed in the atmosphere, our average global temperature would be many tens of Fahrenheit warmer than they are today. So there's huge changes to the heat content in the ocean, and this has ramifications for extreme events. So we've talked a lot today about hurricanes already. They feed off this reservoir of energy, this fuel. So even just a 1 degree increase in the ocean heat content, say in the Gulf of Mexico, has vast impacts on the characteristics of extreme events such as tropical cyclones and attendant flooding, for example.
Added to that, I mean, I think your point is valid. One of the things that most people don't realize is most of the quote-unquote global warming is happening in the oceans. That's about where 90+% of the warming is going. We kind of quibble and argue about that small percentage in the atmosphere, but what I always tell my students at the University of Georgia is that heat in the ocean finds its way back to the atmosphere through hurricanes, through changes in weather patterns, something we haven't talked much about today, but just changes in the heating patterns in the Arctic region, Arctic amplification. That communicates to where we live, even if we don't live in the Arctic and we live in Decula, Georgia, for example, the jet stream patterns that respond to those Arctic amplification changes, some of the scientific studies suggest. So your question about exactly that you're pointing to in your graphic there, the thing the key to understand and why we need global observations is that the Earth system is a connected system. So something happening far off in the Arctic or in the Pacific Ocean can affect where we live.
Thank you. If I might, one more question for Dr. Bostrom and Dr. Sobel. Coral reefs play a very important part of our protection of shorelines as well as our ecosystems. And science seems to be proving that stronger storms and ocean acidification are related. And so what I'd like to ask about is what can we do to reduce ocean acidification and to protect our coral reefs, and what is the correlation between ocean acidification and coral bleaching?
I'm not an expert on corals, so I don't want to give too detailed of an answer, but I do understand from my colleagues who study them that they're in big trouble due to both warming and acidification of the oceans. I can't say the relative roles of both of those, but it's a very serious problem, and I don't know that there's anything that can be done to stop ocean acidification on a practical level other than putting less carbon into the atmosphere. The oceans are taking up a large amount of that, and the ocean's so enormous that you know, one can imagine geoengineering schemes to put something in the ocean to mitigate it, but I don't think those are practical. So, and the same is true for the warming of the ocean. I really think mitigation of greenhouse gas emissions is the only answer there.
Here's a picture of a bleached coral, dead. Anybody else have any thoughts about it?
I would just echo what Dr. Sobel said, that I'm not an expert in any of those things, but it's very clear that the strategies that we have to mitigate what's going on with coral reefs and other potential living systems that help protect the coasts require reducing greenhouse gas emissions. And geoengineering strategies have been tested in the past with limited positive results, as far as I understand, and we are in desperate need of new geoengineering strategies and research on them.
Thank you very much. I yield back.